So now we will be talking about one very important thing called as Laplace smoothing. Now what is this? Let's say you have a text document which is, let's say, very good educational institution. Maybe this very word is not even a part of my data set. So let's say we decided to ignore it. But when we looked at the good educational institution, so we wanted to figure out the probability of education given this particular word. Now, in this case, let's say we saw that the probability of good given education is 0. If you even go back to my previous data set and try to look at it, you will notice that the probability is going to be instead going to be 0. And for remaining, let's say I have 3 by 13, 1 by 13, and the probability for education is anyway 3 by 5. But what is happening due to this? Because one of this probability term got to 0, because it was not a part of my training data set. So that's the reason it turned out that the whole probability became 0. Now this is a problem. If you intuitively think about the statement good educational institution, looks like it should be a part of education. But because of this word not being a part of my training set, the whole probability turned out to be 0 in this case. Now, this problem we can solve it with the help of Laplace smoothing. Let me tell you what exactly is this. So don't get mesmerized by looking at so much of the maths, but I will explain you. It's quite simple. So what we do in this case is we decide that, let's say, this whole thing what you are noticing on this left hand side, this was my original values which we had. Okay, this I have shown you even in the last case. And what we will do in this case, we will add a value 1 in front of each. So you can notice here that I am just going to add 1 in front of each value like this. So what happens due to this? All my values became now basically 1, 1, 1, 1 and so on, right? Means basically all get added by 1. So what is happening, even if the value is 0, it do not became 0, it became basically added by 1. Now, in order to basically go and balance this whole scenario, what we will also do is, we will look at this part, because earlier, if you remember, it used to be like 1 by 13, right? 2 by 13 and so on. But right now, how many values we have added here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So earlier, the total values were 13, but I have added 12 values to it. So it became 25. So now this 12 which I have added here, I need to add in the denominator here as well. Because now the total value which we were earlier dividing by 13 now became 25. So I will add it here. So if you think about it, what we are doing is, we have a value basically which is, let's say, x, whatever it is, plus we have 1 divided by whatever the earlier whole value was there, but divided by plus we are adding the length of vector v, means length of this total value also we are adding it up to it. So that's what we are doing extra in this case, right? So some people sometimes also say that instead of taking the value 1, we can take it like alpha. Okay, but if we are taking by alpha, then alpha into total length of this. That is what you need to do in the division part. Now look at this side also. We are exactly doing the same thing for cinema. So we are adding each term by 1 here, and here we just making sure that we are adding the same total length of the vector, because we have added 12 values, so we divided it by 12 plus as well. So this is gonna make sure that now none of the probability will remain as 0, and we will end up with some good results. So this is how the Laplace smoothing is performed. So I hope now you got the idea. What is Laplace smoothing? It will help you basically not to make your whole probability 0 in case if one of them is 0.